Good morning, good afternoon, or good evening to Dr. Mazida. So for the molecular building and analysis of transition metal complex, our group 33, is chosen the molecule Potassium Ferrocyanide K4 FATIN seeds. My name is CHAU and my other group members are FATIN, NATASYA, and HUIJIE. So for the Potassium Ferrocyanide, it's an inorganic compound and is a potassium salt of coordination complex for ferrocyanide ion, which is FeCN6 4-. The physical properties include its molar mass, density, boiling point, melting point, as mentioned in here. So the molar mass for potassium ferrocyanide in anhydrous form is 368.35 gram per mole, whereas for molar mass in trihydrate form is 422.38 gram per mole. The chemical properties include its reaction of potassium ferrocyanide with sulfuric acid, reaction with the ferric chloride, reaction with chlorine gas, and also the interconvention by oxidation between the potassium ferrocyanide, yellow color, and the Prussian blue. So this is the digital model of potassium ferrocyanide for the ball and stick model. As you can see, the ferrum atom at the middle is linked with the carbon atom with the dative bond, and whereas the carbon atom linked with the nitrogen atom by the covalent bond, which is the triple bond. And potassium ion can form the ionic bond with this anionic, the ferrocyanide ion. The crystal structure of potassium ferrocyanide trihydrate is provided besides. As you can see, the bonds such as the ionic bond, ion dipole force, and the hydrogen bond, they link together in the crystal form. And this is the space filling model for the potassium ferrocyanide, and this is the skeletal structure for the potassium ferrocyanide. The molecular structure details. Potassium ferrocyanide, it consists of cations, potassium ion, and the anion for ferrocyanide ion. So the potassium cations basically is ionically bound to the ferrocyanide anion, which is a coordination complex. The potassium ferrocyanide can interact with each other through the electrostatic attraction between the oppositely charged ions, and it can form hydrogen bond with photomolecules between the electronegative nitrogen atom from ferrocyanide anion and electropositive H atom from H2O molecules. The ion dipole forces formed between K+ ion and electronegative N atom in the ferrocyanide ion. This is the molecular structure details for anion, ferrocyanide ion. So ferrocyanide ion is a covalent compound which composed of the elements iron, carbon, and nitrogen. It's a triple bond, which is the covalent bond that can be formed between the C atom and N atom. The covalent linkage in which C atom and N atom share 3 pairs of electrons, which can make it the overall charge of 1- for the cyanide ion. Since there is presence of 6 cyanide ions, the overall charge for these 6 cyanide ions will be 6-. And the coordinate bond, or also known as dative covalent bond, is formed between cyanide ion and ferrous ion. The coordinate covalent bond in which its cyanide ion donates its lone pair of electrons to the ion. The ion has a +2 oxidation state in the compound, so the total charges of ferrocyanide anion is 4-. The difference in electronegativity between nitrogen and carbon causes the nitrogen atoms to become electronegativity, while carbon atoms become electropositivity. The atomic structure details. There's 4 atoms which are potassium, iron, carbon, and nitrogen. For potassium, the number of electrons is 1 valence electrons in 4s1. Iron atom, valence electrons in 4s2, 3d6. Carbon atom, 4 valence electrons in 2s2, 2p2. Nitrogen atom, 5 valence electrons in 2s2, 2p3, as provided in the orbital diagram stated below. The sp hybridization of Cn-, where the ground state of C- will become hybridization state of C-, and same goes for N. So they will form the sp hybridization of Cn-, which is the cyanide ion. And after that, they will conduct the D2sp3 hybridization of ferrocyanide anion. So this is basically what the shape will look like provided in here. So the total number of valence electrons for potassium ferrocyanide will be around 64. And the sp hybridization of cyanide ion, the hybridization type is sp with bond angle 180 degree, geometry linear. For D2sp3 hybridization of ferrocyanide anion, the hybridization type is D2sp3 and bond angle 90 degree with the geometry of octahedra.
Now I will talk about the type of chemical bonds present in the molecule. The first chemical bond that can be found in this molecule is the covalent bond. The carbon contributes 4 valence electrons and the nitrogen contributes 5, plus the additional electron for the negative charge. In the final ion, the carbon and nitrogen are sharing collectively 6 electrons in a triple bond which ultimately came from both atoms. The next bond is dative bond. Dative bond is formed between ion and cyanide ion in this molecule. Ion atom has vacant orbital with 8 valence electrons, while cyanide ion has unpaired electrons. So dative bond is normally formed between an atom with a lone pair electron and another atom with an empty orbital. The third bond is the ionic bond. Ionic bond is formed between ferrocyanide ion and potassium ion. Since the formal charge of the ferrocyanide ion is 4-, so 4 potassium ions are needed to balance the total ionic charge into 0. So here is the picture of all the chemical bonds that can be found in this molecule. So now I will talk about how does the bonding affect the molecule's properties and behavior. So the first property of this molecule is it is soluble in water. Since nitrogen atoms form 3 covalent bonds with carbon atom, there is an unpaired lone pair electron on the nitrogen atom, which is able to form hydrogen bond with hydrogen ion in water. So the next property is it has high melting point. So ionic bond between potassium ion and the ferrocyanide ion contributed to the high melting and boiling point of this compound. This is because higher heat energy is required to bring the strong ionic bonds between the negatively charged and positively charged ions. Now we will look at the real-world application of potassium ferrocyanide. Potassium ferrocyanide can be used to color some medical foods for specific groups of patients, such as those with kidney or cardiac problems. It is also used as a colorant in foods and beverage, such as jam, jelly, marmalade, and baking powder. Next, it is used in the manufacture of potassium cyanide, which is used extensively in gold mining. Lastly, it is used in tempering of steel and in process engraving. It is employed in the manufacture of pigments and as a chemical reagent.
Next, I'm Fatin and I'm going to explain the next part, which is the positions of each atoms in potassium ferrocyanide and its relation according to the periodic table. As we can see on the slide, I have circled the positions of the atoms, which are potassium ferrum, or known as iron, carbon. Learning back in high school, we know potassium is one of the reactive alkali metals. It is because the metal is located in group 1 of the periodic table. In potassium ferrocyanide, each potassium ion or K+ acts as a counterion, which used to create balance to the negative charge of its complex ion. Potassium's position in the group also indicates it readily forms ions with a +1 charge, which makes it more suitable for balancing the charge of the complex. Next, iron. This element is located in the D block of the transition metal of the periodic table. What makes it more special is that iron has the ability to exhibit variable oxidation states and form coordination complexes, as it has the characteristic feature of transition metals. In potassium ferrocyanide, iron is in the +2 oxidation state, surrounded by 6 cyanide ligands to form the complex ion of ferrocyanide. 6 in the power of 4 negative. Carbon and nitrogen are non-metals and are located in the P block of the periodic table. In potassium ferrocyanide, the cyanide ligands consist of a carbon atom triple bonded to the nitrogen atom. Cyanide is a strong field ligand. Its interaction with the ion influences the magnetic properties of the stability of. This is the reference for the position of the atoms according to the blocks in the On to the next slide, the properties of the atoms in our chosen compound. We start with potassium. Element in group 1 can easily form ionic bonds. It is also known for its low electronegativity and high reactivity. In potassium ferrocyanide, potassium ions K+ act as counterons to its complex. The presence of potassium ions enhances the compound solubility, and meanwhile iron is a transition metal. Transition metals exhibit variable oxidation states. Also, this ability shows great impact, which can form complex ions due to availability to the d orbitals for bonding. To prove my point, iron in potassium ferrocyanide forms coordination bonds with 6 cyanide ligands. This coordination results in octahedral geometry around the ion. Next, carbon and nitrogen. The cyanide ligands in potassium ferrocyanide consists of a carbon atom triple bonded to the nitrogen atom. The strong triple bond between carbon and nitrogen makes cyanide a strong fit ligand, influencing the magnetic properties and the stability of the complex as shown in the picture. Last but not least, the properties of potassium ferrocyanide in everyday life. We have galvanization used in the industry to remove hydrogen gas bubble on the surface of the metal, photography used in blueprinting, dyeing in textiles, and coloring ceramics, research purposes, and act as anti-caking agent in bakery products.